All right, in this lesson, we're going to talk about the last type of conic section, hyperbolas. We've already talked about circles, parabolas, and ellipses. So hyperbolas are probably a new shape for you. This is a hyperbola right here that you can see in blue. And we'll talk about the parts of a hyperbola. You have, of course, your center, okay? And then you've got the two vertices are basically what you would normally think of as the maximum and minimum on a parabola. That very bottom or very top of the curve, those 2 points are vertices. Then the 2 points, just like in a parabola that you have, are foci, where everything kind of focuses to that point. You're going to have those 2 points also. Now there's a line that connects all those points. Okay, it's not part of the hyperbola, but it's important to understand that all 5 of those points lie on the same line, and we call that line the transverse axis. So you can see that right there in red. Okay, now the distance from the center to each vertex is going to be represented by the letter A, and the distance from the center to each foci is going to be represented by the letter C. And we have this formula, A squared plus B squared equals C squared, of course the Pythagorean theorem. So, for ellipses, we just change it to a minus, but for hyperbolas, we actually use the Pythagorean theorem. Okay, and you're like, well, what is B? Well, B is the distance from the center kind of out here to a certain point, and we'll end up making a box around those 4 points whenever we graph it. But we'll get to that here in a little bit. B, we don't really have a specific name for the point that you get to. We'll use it whenever we make our shape. Okay, but that's the basic shape of a hyperbola. Okay, so first let's find the standard equation of a hyperbola. So similar to ellipses, there's 2 different possibilities. You could have x minus h squared, okay, over a, and of course y minus k squared over b equals 1. So far everything looks very similar to an ellipse, right? It's the exact same as an ellipse. But with a hyperbola, you have a minus in between the 2 fractions instead of a plus. Okay, so that's one possibility. The other possibility is that your y minus k is on the positive fraction, and the x minus h is the one that's on the negative fraction. Okay, so in this situation, A is always going to be the letter on the positive fraction, and B is always going to be on the negative fraction. Okay, so you just swap the x minus h and the y minus k this time instead of swapping A and B under the x and the y. Okay, so it's going to be either one of those. Now it's important to realize how that changes your hyperbola. Just like with an ellipse, you don't need to draw this, but just like with an ellipse, you can have a vertical ellipse or a horizontal ellipse. Same thing with hyperbola. Okay, you can have a horizontal hyperbola, or you can have a vertical hyperbola, like that. Okay, so the difference is going to come with whether y is the positive fraction or whether x is the positive fraction. Okay, if x is the positive fraction, then your transverse axis is going to be horizontal like this. So this is when x is positive. Okay, not really x being positive, but x is the fraction that's positive. This blue one right here. Okay, maybe I should draw this one in blue. So this one is the one with the blue fraction. And then the red one up here, the red formula, is if you have a vertical transverse axis, like that connects your center, your foci, your vertices, all that stuff. Okay, so one of those 2 hyperbolas is what's going to happen, depending on which fraction is positive. So it says find the standard form of the equation of the hyperbola having a foci at -1, 2, and at 5, 2, and vertices at 0, 2, and at 4, 2. Okay, so let's just draw a little sketch real quick. We've got foci at -1, 2, so somewhere right in here. We've got another foci at 5, 2, so somewhere over here. And then we've got vertices at 0, 2, and at 4, 2. All right, so that's going to mean our parabola looks something like that, because those are our vertices, and then the foci are inside of each part of the hyperbola. Okay, so that just gives a little sketch, an idea of what our graph's going to look like. So now, since our transverse axis, you can see, is horizontal, then the x is going to be positive. So we're going to use this formula right here. where the x is on the positive fraction. So what we need to figure out are what are A and what are B. Well, A is the distance from the center, right? The center of the two hyperbolas to each vertex. So we've got to figure out what's the center. So if our two vertices are 0, 2, and 4, 2, well, what's halfway between those? So add the x's, 0 plus 4 is 4. Add the y's, 2 plus 2 is 4. So the coordinate 2, 2 is at the center. So 2, 2 is, of course, right there. Okay, so if 2, 2 is the center, then what is the value of A? Well, again, A is the distance from the center to each vertex, so the distance from 2, 2 to 0, 2 is 2. Okay, and then C is the distance from each foci to the center. So how far is the point 5, 2 away from the center 2, 2? Well, it's 3 away, so C is 3. Okay, so now using the Pythagorean theorem, you can find B. 2 squared plus B squared equals, 3 squared. So 3 squared is 9, 2 squared is 4. Subtract 4, so B squared equals 5, and then take the square root. So B equals the square root of 5. Okay, so we know A and B. Now we can plug them into our formula with the center, which is of course HK, 2, 2. So we're going to use, now and kind of highlight this, we're going to use the center, we're going to use A, and we're going to use B to write our formula. And remember, we're using the blue formula because we noticed that our transverse axis went horizontally, so therefore x has to go above the positive fraction, the value of A. All right, so our formula is going to be x minus h, which is 2, squared, over A squared, right? So did I say it was A? My fault. A squared and B squared. Just like ellipses. It's the same as ellipses, just there's a minus in there. That's my fault. So add those squares. So we got A squared and B squared. So again, A was 2, so 2 squared is 4. Then you have minus y minus k. Well, k was also 2, right? Because our center is 2, 2 squared over, and then we have B squared. Well, it's the square root of 5 squared, which is just 5. So you have over 5, and then you make it equal 1. So here is the standard form of this hyperbola. Okay, so go ahead and pause it, give this problem a try, and then I'll go over it. You can see in the upper right here, I drew a little sketch of my vertices and foci, and I notice now my axis is going to be going, my transverse axis is going vertically, which means that the y value is going to be the one on the positive fraction. So the y binomial that we use is on the positive one. So this is going to be more like the, we're going to write this one like the red formula up here, where y minus k is on the positive fraction. Okay, so then let's figure out what is the center. So we do the midpoint formula for the two vertices, 4, 1 and 4, 9. Find the middle of the vertices, and we get the point 4, 5. So 4, 5 is our center, which is our h and k. Now, A is the distance that each of the vertices are from the center. Well, they're both 4 away, so A is 4. And then C is the distance the foci are from the center. They're both 5 away from the center, so C is 5. Now we use Pythagorean theorem with the A and C to find B. So when we solve that, we get B equals 3. Now we just take A and B, being 4 and 3, and then our center, which is HK, 4, 5, and plug them into the blue formula that we had at the top. So we put the y minus k part over the positive fraction. The first fraction is positive, so we do y minus 5 squared over, and of course A is 4, so we put it over 16, because that's 4 squared, minus x minus 4 squared over b squared, which is 3, so over 9, and it equals 1. So there's our standard form for that hyperbola. Okay, so right here we're given, we're given an equation, and we want to sketch the graph. So what we got to do first is make it equal 1. So I'm going to do 4x squared minus y squared equals 16, and we'll divide everything by 16, just like we did for ellipses. So this isn't much different yet. 4 over 16 reduces to 4, and then we've got y squared over 16. Okay, so first thing you want to identify is the center. Now that we've got it in the proper form, our center is of course 0, 0, because h and k are 0. Now we got to identify what's A and what's B. A is the value from the positive fraction, right? So A is the square root of 4. Remember, you have to take the square root of it because 4 is actually A squared. So you take the square root to find A, and then B is the value from the negative fraction. So the square root of 16 is 4. So A is 2 and B is 4. So what we're going to do to graph this now is we're going to start with our center at 0, 0. Okay. A remembers the distance to the vertices, right, to each vertex. So it's important now to realize, well, are my vertices above and below the center? Or are they to the left and right? Well, where did you get A from? We got A, remember, from this fraction. It had an X on the top. So that means our vertices are going to, remember, the transverse axis is going to go along the x-axis. It's going to be a flat transverse axis. So that means we're going to go left and right to put our vertices. So I go left 2 and right 2 to plot my vertices. All right. Now what B is, okay, we haven't done anything with B yet. B is the points that you know, if you went up and down, that's where you would put the points for B. So I'm going to go up 4 and down 4, put my points for B. Okay, now this is going to help us when we draw our hyperbola. So what you want to do now is make a box around these 4 points. So I'm going to make just a dotted line box. I'm not going to make it solid. Just make that box around. You're like, well, why do you do that? Okay, so here's what you want to do. You want to now draw the diagonals. Okay, so if I drew a diagonal through the center and one corner, all right, and just keep that diagonal going. Okay, do your best to draw it straight, obviously. Okay, so we're going to draw those diagonals through the center. Now, what those lines do is they give us asymptotes. Okay, it's important to understand that a hyperbola is not like a parabola. And you know how a parabola will go down and it'll come up. And remember, those curves keep getting closer and closer together, right? As they come up, they keep getting more and more vertical, right? But with a hyperbola, it's not like a parabola. They actually keep getting further and further apart. A hyperbola does this right here. They'll keep getting closer and closer to certain lines out here. Okay, so it's going to end up looking more like a V than a U shape if you zoom out on it. All right, so that's what these lines do, is they tell us those values that they approach, those lines that are going to approach as an asymptote. So now what you would just do to draw your hyperbola is you've got your vertex out here, so you're going to just draw a curve and make it come out like it's approaching those asymptotes, okay, on either side. All right, so those red lines right there, those represent the hyperbola. Everything else was just construction to help us sketch the graph of the hyperbola. Okay, so that's how you do a hyperbola. Go ahead and see if you can do the U try down here, and then we'll go over. Okay, so when we divide by 36, we get x squared over 9 minus y squared over 4 equals 1. So then you can identify your centers, of course, 0, 0. A is the square root of 9, which is 3, and B is the square root of 4, which is 2. Remember, A comes from the positive fraction. All right, so then when we plot our center, 0, 0, and then I go 3 on the x-axis, because remember, we got A from underneath x squared. So we're going to go 3 along the x-axis and put our vertices. So 3 to the right, 3 to the left give us our vertices, and then 2 above and 2 below the center give us the points to draw our box. Then we draw a box around the vertices and the points we got from B, and then we draw the diagonals through that box, and that shows us the asymptotes for our hyperbola. Then we go back to our vertices at negative 3, 0 and 3, 0, and from there we start our hyperbola and draw the curve towards the asymptotes in either direction. And that'll give us a good hyperbola for this equation. Okay, one thing to understand also is like being able to write the equation of the asymptotes. So for this, let me kind of retrace this asymptote right here. A lot of times they want to know what's the equation of that. Well, you know, all you got to do is pick out any point and count the slope, rise over run, and plug them into point slope formula. Y minus y1 equals m times x minus x1. So that one is, you know, the rise is going to go up 2 over 3. So m is 2/3. And then any points, we can plug in the point 0, 0, x minus 0. We know it goes through that because that's the center, y minus 0. So the asymptote is y equals 2/3 x. Okay, so that's one, and then the other one is always going to be the same thing, but the negative slope. So the other one's y equals negative 2/3 x. Okay, so they're always going to be the exact same formula, except the slope is going to be positive, and the other one's going to be negative. All right, so just a little side note, something that they might ask you for, what are the equations of the asymptotes? So there they are. That's how you do that. Okay, so let's look at graphing a hyperbola when it's given to us in the general form as opposed to in standard form that we're used to. So this is one thing we've done before. We've got to take this and complete the square in order to write it in standard form. So let's group the x's together and group the y's together, and then we'll move the constant number to the other side. Okay, so now with the x's, we need to complete the square. So we're going to have to factor out the GCF of 4, which is x squared plus 2x. There is no GCF for the y squared, so we just leave it as minus 3y squared. We don't have to worry about completing the square out there. All right, so let's complete the square now. What would we put in this blank space? Well, remember, you take half of the number in front of x, which is 2 in this case. So we take half of 2 and square it. So that's 1 squared, which is 1. So we're going to add in 1. Now again, it's important to understand, you've got a GCF that's multiplying everything. So 4 multiplies that 1. So we really added 4 to the left side, which means we need to add 4 to the right side. Okay, then at this point we can go ahead and factor 4x, or the x squared plus 2x plus 1 is going to factor into x plus 1 squared. And then we got minus 3y squared equals negative 16 plus 4 is negative 12. So we need to make sure that that right side equals 1, so we need to divide everything by negative 12. So we're going to divide each fraction over here by negative 12. And when we do that, notice it changes which one is positive and which one's negative. Now the y is positive, so we'll put it towards the front. Y squared over, and 3 over 12 reduces to 4. The negative over negative makes it positive. Then the other one becomes negative, and it's 4 over 12, which reduces to 1 over 3. So we have 3 on the bottom, and then up here we have x plus 1 squared equals 1. All right, so now that we have our equation written in standard form, we can identify what's the center, what is A, what is B, and graph our hyperbola. So the center for the x coordinate is negative 1, right? Because we've got to take the opposite of the plus 1 that was in there. And then the y one is 0. Then the value for A is the square root of 4, which is 2. And the value of B is the square root of 3. Okay, which is kind of messy, but sometimes you just got to deal with it not being a perfect square that you're taking the square root of. Okay, so now we can sketch a graph by graphing our center, negative 1, 0, right here. And then A is 2. Now remember this, on this one, 2 came from a fraction with y, right? So that means that our transverse axis is going to go vertically this time. A is going to count up and down. So we're going to go up 2 from there and down 2 from there to get A. And now B is the square root of 3. The square root of 3 is some value between 1 and 2. I think it's like 1.4, 1.7. Let me do it real quick and make sure. So square root of 3 is 1.7, yeah. So we're going to go about 1.7 along the x-axis from the center. So 1.7 would be somewhere around in here, and then 1.7 this direction, somewhere around in there. All right, and then we can draw our box around it, and then draw the diagonals through that box to get our asymptotes. So then when we graph this one, the A value went up and down. So our vertices are here and here. So this time this is going to be a hyperbola that goes up, opens up and down. Okay, so there's a good example of this hyperbola. You just had to change from the general form to the standard form. Now on this one, again, if they ask you for what are the or the equations of the asymptotes, well, you got to count rise and run. So we would rise 2, right? This line is rising 2 and running square root of 3. So your slope is 2 over the square root of 3. And then you plug it in with the point, you can use negative 1, 0, and y, y minus the y coordinate would be 0 equals m times x minus the x coordinate is x plus 1. and then you have to distribute and solve and make sure you do a positive and a negative for each of those fractions. And of course, you can't leave a square on the bottom, so you have to simplify by moving your square root to the top. We've done that a bunch. All right, so see if you can take this one, change the general form to the standard form, and then graph it. So the beginning of this one, we of course want to subtract the 18 and group our x's together and our y's together. So after you do that, now we want to take out the GCF for the x's, so we take out a 9, which leaves x squared minus 4x. And then with the y's, we want to take out a negative. Okay, so it seems strange to just take out a negative, but you don't want to leave y squared as positive. So we take out a negative, which makes y, or you don't want to leave y squared as negative, so we take out the negative, which changes y squared to be positive, and it also changes the minus 6y to be a positive 6y. All right, then we leave spaces to complete the square. All right, so to complete the square, of course, we're going to take half of 4, right? Because, negative 4, because negative 4 is in front of the x, so half of negative 4 is negative 2, and then we square that and get 4. So we add in 4 on the left. Now realize that 4 has a common factor here of 9, so 9 times 4 is 36. We really added 36, so on the right side, we go ahead and add 36 right there in red also. Then for the y squared term, we've got to take half of 6. Half of 6 is 3. 3 squared is 9. So we add in 9. But remember, we factored out a minus. So we really subtracted 9 because that minus will distribute to the 9 and make it minus 9. So on the right side, we have to subtract 9 to make sure it stays balanced. All right, now at this point, we can factor on the left, and we get 9 times x minus 2 squared minus y plus 3 squared equals, and then we add up 36 minus 9 and minus 18, and that gives us positive 9. So now to finish it off, we just need to divide by 9. So we divide everything by 9, which gives us x minus 2 squared minus y plus 3 squared over 9 equals 1. All right, so that's our standard form. We can identify A and B in our center. Our center is at 2, negative 3. A is on the positive fraction. Well, there's nothing there, but we understand that that's over 1. So A is the square root of 1, which is 1. And then B is the square root of 9, which is 3. So from there we can plot our center, 2, negative 3. And then A is 1. That's how far we go from the center to the vertices. We got 1 from the fraction of x. So we're going to go 1 on the x-axis to get to our vertices. And then we go 3 along the y-axis to help us draw our box. So now we can draw a box around these points. And of course draw the diagonals through those points. Alright, and that gives us the asymptotes. So our vertices were right here and here. So this is going to be a very tall, thin hyperbola. Alright, so that would be the hyperbola for this problem. Let me know if you have any questions on that. I know it's not real simple, but I'll help you out if you need it. All right, last thing we need to talk about with conics. Okay, so this is going back to just all conics in general, is classifying. So if I give you the standard form of the equation, can you tell me, is that an equation of a circle, a parabola, a hyperbola, or an ellipse? Which one of the 4 is it? And there's a way I'm going to show you to tell me this based off of a little formula that you're actually pretty familiar with, or should be something that you've done in the past. So what you want to do first is realize the general form of a conic, ax squared plus capital B xy plus c y squared plus dx plus ey plus f equals 0. So it's a lot in here, but essentially you've got a term for everything. You've got a term for x squared, you've got a term for y squared, you've got a term just for x's, you've got a term just for y, and then you've got a term for a constant number without any x's or y's, and then you've got a term that's got an x and a y, so bxy. All right, so we use this right here to determine what is A, B, and C, which are the ones that are important to figure out what shape it is. So what you've got to do to determine the shape is figure out what we call the determinant. Okay, so the determinant is b squared minus 4ac. Now, if that sounds familiar, it's because it's exactly what you use in the quadratic formula. So what you wanted to do is determine what is the value of b squared minus 4ac. If that value is a positive number, so greater than 0, then you have a hyperbola. Let me write that the other way around. Okay, if that's greater than 0, then you have a hyperbola. Okay, if b squared minus 4ac equals 0, then you have a parabola. And if b squared minus 4ac is less than 0, then it's either a circle or ellipse. Okay, and it depends on whether a and c are the same or not. So if you have it be negative, then it's a circle if a equals c, and it's an ellipse if a does not equal c. Okay, so that's the four possibilities that could happen. It's more than 0, it's a hyperbola. It equals 0, it's a parabola. If it's less than 0 and a and c are the same, then it's a circle. If it's less than 0 but a and c are not the same, then it's going to be an ellipse. All right, so let's test this right here. So notice a, b, and c. That's where we get those. So a is in front of x squared, b is in front of xy, and c is in front of y squared. So let's figure out what is b squared minus 4ac. So right here, a is 4. There is no xy, so b is 0. And there's no y squared, so c is 0. Right? So we've got a is going to be 4, b is 0, and c is 0. So let's plug them into b squared minus 4ac. 0 squared minus 4 times 4 times 0. So 0 minus, well, 0 equals 0. So whenever this value equals 0, we know that we have a parabola. So this first one, I'll write up here, is a parabola. Okay? Now let's test it for the second one. So this time a is 4, b is in front of xy. Well, I don't see an xy, so that would be a 0. C is in front of the y squared, so that's negative 1, right? So c is negative 1. So let's plug it in this time. B squared, 0 squared, minus 4 times a, which is 4, times c, which is negative 1. So I got 0 squared is 0, minus 4 times minus 1 makes it plus 16. So it's positive. Whenever it's positive, it's a hyperbola. So this one is a hyperbola. Okay? See if you guys can do the U tries down at the bottom, and then we'll go over them. Okay, so this first one, you can see a is 2, b is 0, c is 4. When we plug them into b squared minus 4ac, we get negative 32. So since it's negative, we have either a circle or an ellipse. The way you know is, does a equal c or not? If a is c, then it's a circle. If a is not c, then it's an ellipse. So in this first one, a is 2 and b and c is 4. Since they're different, that means it must be an ellipse. All right, so for b, do the same thing. A is 2, b is 0, c is 2. Plug it into b squared minus 4ac, we get negative 16. So again, it's negative, so it's either a circle or an ellipse. If it's a and c, if a and c are the same, then it's a circle. In this case, a and c are both 2, so this one is a circle. All right, so that's hyperbolas, and also how to classify conics using the determinant. So let me know if you have any questions on any of this, and not the determinant, sorry, the discriminant. Let me know if you have any questions on this, and you can practice the problems on the first slide.